go through completing the square. So we have a quadratic here, and it's in standard form. That's what's important. To complete the square, we need to be in standard form, and the general equation for standard form looks like this. So you're looking for anything that kind of looks like ax squared plus b, and I'm going to use different colors because it'll help us as we go through this algorithm, plus c. We started a little late. Okay. So our goal here is to get to a vertex form. Okay, and the vertex form, the general equation looks like this. Y equals, still has an a, but it has, hope that doesn't happen. There we go, sorry. X minus, sorry, my computer said it was going to restart for a second. I think I got rid of it. X squared plus k. Okay, so what we're going to do here is the very first step is you actually divide the first two terms by the a coefficient. So in this case, that's 2. So we divide these two terms by 2. So that becomes the common term that we've pulled out. When we do that, whatever's left over, we have x squared minus 13x, okay? And then plus 169. The next step here is we're trying to create a perfect square trinomial in the middle. This is what we're trying to do. So we're going to take this. This is our new b. We can say like bn if we want. And this is where we do that little calculation on the side where bn divided by 2, and then we square it. So in this case, that's going to be negative 13. Okay. And it's going to be a fraction for us. Negative 13 divided by 2 squared. I can leave it as a fraction, or you can put it as a decimal, whichever is easier for you. I'm going to keep it as a fraction. Negative 13, negative times negative is positive, and it's 169 over 4. I'm going to leave it as a fraction because it's actually going to help me for my next part. You can put it as a decimal as you like. We're going to take that term, and we need to like add and subtract it in those brackets. So our next line is going to read y is equal, we keep the 2 outside, we keep the x squared, we keep the negative 13x, and then we add this new number, okay? And just let's pretend that it's an easy number here. 169 over 4, okay? It's going to be easier when we do it one last step on the outside. The next thing we have to do is we actually got to bring the negative term outside of this bracket, okay? Because we only want to have 3 terms, 1, 2, 3, technically have 4 at the moment. We want to bring it to the outside. We decompose that one term. And the reason we're allowed to do that is because if you put those two together, they equal 0. So adding or subtracting 0 or anything doesn't change it. But in terms of the algorithm, we got to bring it out. And when we do that, we got to multiply by that coefficient. So I got to multiply by 2. Now that could get a little tricky. Oops. I have y is equal to 2 x squared minus 13x. I still have that positive 169 over 4. Multiplying this fraction by 2 gets tricky. 169 times 2. But I know a little trick. Because there's a 2 on the top and a 4 on the bottom, I can just reduce my bottom value there, and I'm going to end up with negative 169 over 2 plus 169, okay? That, if you know fractions, that trick is really simple. If not, you might want to just use it as a decimal, and you'd get half of whatever that is. The reason we've done that is because this in the middle now is called a perfect square trinomial. And what that means is if I square root the first and the last term and I just bring down the middle operator, I can represent it as one bracket. One bracket squared, which is what our vertex form is going to look like. So if I take the square root of x squared, that's okay. That's the x. The operator in the middle is a negative, and the square root of 169 over 4 might seem daunting, but it's actually not. I just take the square root of the top term, and I actually squared a number to get to it. So it's actually 13. And the square root of 4 is 2. I know that's my answer. It's 13 over 2. So that's why I left it as a fraction. It was actually really easy to square root, where that decimal would have been a disaster probably to square root after. The only tricky part here is now this. When I go to combine the two of them, technically I need them to be, to have, what's it called? Oh my gosh. Common denominators. So I'm going to make a common denominator of 2 here, which means this is going to be, I'm going to have to multiply that by 2 anyways. That's 170 twice is 340 minus 2, 338. So this should be 338 over 2. My final vertex form will look like this. Negative 13 over 2. And that is going to be plus 169 over 2 as our final value. Okay, so there's our vertex form. These will be decimals if it's easier for the read. But what's the goal here is that we just turned, and don't mind the other math on the outside there, we turned this from standard form, okay, to vertex form. And vertex form is good because I can find the x value and the y value of the vertex, and they happen to be the h and the k. And here's our h, so that's 13 over 2, and our k, which is 169 over 2. So we found that really quickly in that question.